Shall we start, or are we expecting more people to join?
So we'll wait another 5 minutes, sir. We'll start, sir.
Okay, so thank you.
So we'll start, sir.
Okay, sir. Let me share my screen. Are you able to see my screen?
Yes, sir.
Okay. Thank you. So thank you for joining me in this class today. Yesterday, I could not complete all the content that I wanted to. So I requested for a short session to cover the remaining content. Okay, so yesterday we discussed layers up to the transport layer. We discussed about the TCP protocol. We discussed about UDP protocol. What I wanted to start with is the type of attacks that can take place on this layer. Okay, so the first type of a TCP attack is called a SYN flood. So if you remember yesterday, I mentioned during the three-way handshake, right, you'll have a SYN packet that gets sent. So in a SYN flood attack, what happens is the attacker repeatedly sends SYN packets to every port on the targeted server. Now, whenever the attacker sends a SYN packet, the computer has to reserve some resources, for example, memory. If an attacker keeps filling up that buffer, what happens is that system will eventually run out of resources and it will cause a system crash. Okay. The next type of attack is called the TCP Reset Attack. So as I mentioned, we can set a reset flag within the TCP header to reset a connection. So what if the attacker inserts himself in the middle of a communication and he sends a reset packet by spoofing your IP address? What will happen is it will terminate the connection. So this is another type of attack. The third type of attack is called the TCP Session Hijacking Attack. Okay, which is again somewhere where the attacker can inject his or her own data into the connection by spoofing their IP address. Of course, the attacker has to have knowledge of all the sequence numbers, the acknowledgement numbers that are traveling through the connection. And if he's able to capture those packets and insert himself into the communication, then he can hijack the TCP session. The last type of TCP attack is called a Christmas tree attack. Okay, so the flags that are shown in the TCP header, only certain combinations make sense to the recipient. Okay, so what if an attacker were to spoof a packet and set flags indiscriminately? So that type of an attack is called a Christmas tree attack, and that's usually used to cause a crashing of the system. Okay. So I think we pretty much covered the transport layer, which is the most important layer within the OSI model. So next, let's go on to the network layer. So the network layer, again, it deals with logical addressing. So logical addressing's equivalent is what's called IP address. So you must have at least encountered this term at least once in the last few years, I hope, but we'll cover it once again here. So with the IP address, there are two types of IP addresses these days. We have what's called IPv4 addressing, and the newer type of addressing is called IPv6 addressing. Okay. So we'll talk about IPv4 addressing in this class. I won't cover IPv6 addressing, but knowing IPv4 may be sufficient for our needs here. So IP address is a unique address assigned to a host on the network. There cannot be more than one host with the same IP address. Okay. An IP address has 4 octets. Okay. So each octet has 8 bits. So when you consider these as binaries, they will eventually convert into decimal. Okay. So we don't really see the binary addresses when we look at our computers. We will always see the decimal numbers for IP addresses. So 8 bits for each octet means an IP address will have a total of 32 bits. Okay. So the IP addresses, because they're 8 bits, the possible ranges start from 0 to 255. Okay. So just in order to make sense of these IP addressing, in order to make sure they are used optimally, they were divided into classes. Okay. So the classes are A, B, C, D, and E. The ranges for class A are, as you can see here, 1.0.0.0 to 126.255.255.255. So similarly, you have class B, class C. Class D and class E are not really used. So on the real world, you'll mostly encounter classes A, B, and C. Okay. So with an IP address, you must also be able to define what's called a subnet mask. A subnet mask will tell you what network your computer belongs to. So, IP address is like a door number. A subnet mask is like your street address for your home. So although your door number might be unique, right, you still have some kind of neighborhood or network or a street that you have to belong to in order to identify where your house is located. Okay, so the subnet masks are always used in conjunction with an IP address to exactly determine where to route a packet. Okay, so where do I see this information? So if I go into my command prompt, this is a Windows system. I try ipconfig. Okay, it gives me the IP address. Here I'm looking at the Wi-Fi address. So this is my IPv4 address. And it also needs to know what the subnet mask is. Okay, and there is also what's called a default gateway. We will cover that. So when you use a subnet mask mask's digits that end with 255, right? So they tell you what network your host belongs to. The remaining 0 tells the actual number that my host has taken. Okay, so when a packet is routed for this subnet masks, it look at this information and it'll tell, okay, this is the network I have to get to, and this is the host number. Okay, so because the first 3 octets belong to the network, I can only define the last octet for hosts on my network. So which means for 8 bits, I have a range between 0 to 255. So the maximum number of hosts I can define is 0 to 255 hosts. Usually 0 and 255 are not used. So they are used for broadcasting. So I can use numbers between 192.168.1.1 and 192.168.1.254 for all the hosts on my home network. Does this make sense? Okay. So there are certain addresses reserved for loopback testing. So example 127.0.0.1, if you use that number, it usually means the same host that you're on. So if I just attempt to reach, so a ping is a command that's used to test the reachability of a particular host, okay? So when I use a reserved IP address for loopback testing, it will usually ping my own computer, okay? And it will see whether my computer is reachable. So similarly, you have certain IP addresses that are reserved for loopback testing. Because of how the internet has exploded, we have run out of IPv4 ranges. Okay, there is no more unique addresses that can be allocated. So that's why we have moved on to IPv6 addresses. But IPv4 addresses are still in prevalent use, at least internally for organizations, okay? And that's called private IP addresses, okay? So within what's called an intranet, or my home network, as I've showed you, it will typically use a private IP address, okay? So within these classes that we have seen here, A, B, and C, you have a range that only reserved for private networks like my home network or your company's network. These are not visible outside on the internet, okay? These are only meant to be used within a given LAN network. So the ranges are 10.0.0.0 to 10.255.255.255 for class A. For class B, it's 172.16.0.0 to 172.16.31.255 with this subnet mask. Class C, again, 192.168.0.0, 192.168.255, and this is a subnet mask. Okay, at least for your knowledge, if you don't even have an in-depth knowledge of IP addressing works, if you look at an IP address, you should be able to at least say which is a public IP address and which is a private IP address. Okay, so when I showed you my IP address, okay, it shows 192.168.1.7 on my computer. Okay, so which belongs to a class C private IP address. So 192.168.0.0. So it's within this range. However, if I were to go to the internet and look at my IP address, right? There is a website that's called whatismyipaddress.com. Okay, it shows another IP address. So this is a public IP address. So while my computer has its own private IP address, when it goes out to the internet, it has a public IP address. So this is possible because of a concept called network address translation. So it is performed by my home router, and it's also performed by firewalls and different network devices at organizations. So internally, you will be using a private IP, and externally, you will be using a public IP. So in between, a device, a router will make the address translation for you. Any questions so far? Okay. So similar to what we saw in a TCP header, we also have an IPv4 header that's encapsulating a segment. So the other fields are not too important. Just know that you'll have a source and destination address within an IP header. So there are several types of attacks that can take place with an IP address, and it causes much confusion. One of them is a denial of service attack. A denial of service attack is used to take down the network of your victim. Okay, so if you continually ping or hit an IP address, a device will eventually get saturated. So what attackers do is they recruit computer systems on the internet, infect them with malware, and have those computers attack a victim computer, okay, or victim network. What will happen is the router or the firewall that's at the edge of a network will get saturated with these attacks. When an IP address is constantly, or multiple IP addresses are constantly connecting to an edge device, they will eventually get saturated. At first, they will all drop the connections, but eventually they'll just hang the CPU. All devices will have a CPU. The CPU will get saturated, and eventually the network will go down. So this is prevalent these days. Although it does not have any kind of monetary benefit for an attacker, sometimes people called hacktivists, they for political purposes, they try to take down governmental networks or websites, things like that. So there is what's called an IP spoofing attack. So it is relatively easy to spoof an IP address. So when I showed you my IP address is 117, on my browser, right? 117 dot something. An attacker can very well spoof the IP address or duplicate the IP address and make it look like the IP packet originated from me. Okay. And this type of spoofing attack is used majorly by governments who are trying to attack other governments. Say, for example, some country like Russia will attack the US and claim that the attack came from Iran. Okay. And because of the possibility of an IP spoofing attack, it is relatively difficult to claim that an attack came from this country or attack came from other countries. So that is the reason why when somebody comes out after an attack and says, hey, an attack likely came from China or Iraq or Iran, there is no concrete evidence to actually pin it on that country. Because you can say based on this IP address, I can say this attack here from this country, but because of the ability to spoof an IP, you cannot deterministically say, oh, this is based on this, I can convict a country or, to say this attacker did this. And the last type of attack is called a Bgp hijacking attack. In this type of an attack, BGP is a protocol. It's a protocol used by your routers at the edge of a network to advertise that, for these set of IP addresses, this is the best possible destination, or I hold the best possible route to the destination. If someone were to wrongly advertise a BGP route, it happened a few years ago, like Pakistan inadvertently sent out a BGP advertisement. What will happen is, if it wrongly advertises a route, that route gets replicated to all the routers on the internet. What will happen is all the traffic will then get routed to the attacker's BGP router. So it will cause a lot of confusion on the internet. So these are some type of cybersecurity attacks that take place at the IP layer. Any questions? Okay. So next we go down to layer 2. That's called the data link layer. So at the data link layer, what we have it's called frame, and we have what's called a MAC address. So as you can see on my screen, the data gets encapsulated, the IP packet gets encapsulated within a frame, and what gets added is a source MAC address and a destination MAC address. So as I stated previously, a MAC address is a physical address. Okay. So where do I see this? Let's pull another command that hopefully this gives. Okay. So if you look at this information over here, if if you see this physical address over here, this is what's called the MAC address. So as I told you previously, MAC address is unique to the adapter, the network adapter installed on your device. It's, it's on your mobile phones, it's on my computer. So any device that connects to the network will have a unique physical address. So it's usually 48 bits, and it's represented as a string of 12 hexadecimal digits. So hexadecimal go from 0 to 9, 8, and then from A to F. So whereas I told you, IP addresses and layer 4 TCP protocols are concerned with delivery of packets from the source to whichever destination in the world. MAC address routing is only concerned with routing the packet to the next hop. What is the next step in the route? So there are a couple of attacks that's possible at the data link layer. One of them is called ARP poisoning, and the other one is MAC address spoofing. So these two attacks will be clear if I explain the next concept for you. Okay. So I will show you how a packet actually gets routed across networks. Okay, we'll go through an example. So let's say I have a host here, and this host wants to send some kind of data. It could be across the internet, it could be across a different network within the same organization, or to a vendor or customer, to another computer on the right side of my screen. So let's name this computer A, and let's name this computer as like F, right? So these two computers are located across different networks. Now, let's say this is the first time you're setting up this computer or this entire network. It doesn't have any knowledge of any of the network that's currently set up. So my computer has called what's called an ARP table. Okay, it's called Address Resolution Protocol. An ARP table maps IP addresses, MAC addresses. Okay, so my computer has this. Computer A has this table over here. I want to go look at it. There is a command to do it. R-A. So for different IP addresses, you can see it has a mapping of the MAC addresses. Okay. So let's say computer A wants to send a packet to computer F. It has an IP address of 192.168.100.10. And let's say it has a MAC address of like the last 4 MAC addresses. It's a long one, but let's say it's A. Okay. Now it has to figure out, it already knows the IP address of F. Okay. That's a given because higher layer protocols, like when you do the DNS name resolution and all that, it'll know that F has an IP address outside of its own network. Let's give this an IP address. 172.16.110. It already knows this IP address. And because it knows the IP address of F, it knows that it has to get to a different network. So in order to get to a different network, it knows it has to first hit the default gateway. So when I showed you IP configuration, it has a default gateway's IP address. Okay. So in this configuration, the default gateway will always be a router. So switch is a layer 2 device. So in in an organization, typically, you'll have switches that are usually kind of used to kind of talk to different devices in your LAN. In a home network, you usually only have your broadband router, but within organizations, you'll have switches for layer 2, you'll have routers for layer 3, you have firewalls for layer 4 at different parts of the network, okay? So the computers over here on the left side of your screen, they're all connected to the same LAN, okay? If it has to just send a packet to this computer over here, let's say this is computer C. Oops. Okay. It only needs to send the data through the switch. Okay, only when it wants to go send it to another network, it has to go through the default gateway, which is the router over here. Okay, let's say the IP address of this router is 192.168.100.1. Okay, so it has the default gateway's IP address. So I told you my computer has what's called an ARP table. Because it's the first time it's connecting to this network, it does not know the MAC address of my router. So it'll ask the question. It'll ask a question, who has the MAC address of the router? Tell me. Okay, so that will get sent out through the switch. It will send a broadcast out to all devices. So where can we see that type of a request? So yesterday I showed you Wireshark captures, and I've already filtered it for you. So here is my computer, my Linux computer, making the ARP request. Okay, so once the switch gets an ARP request, it will send it out to all the devices connected to its ports. The switch has what's called a MAC address table. The MAC address table is essentially a mapping of MAC addresses. So it says AAA is connected to port 1, then BBBB is connected to port 2. Okay. So it will send a broadcast packet to all the devices on this LAN. And whichever devices has that MAC address will respond to the ARP request. Okay. So let's say an ARP request comes out, it has to know the MAC address. So it gets broadcasted to all the devices. And the router gets it and it says, hey, I have this MAC address. And it'll send it back to my computer. So once my computer receives that response, it'll populate the ARP table. So it'll say, okay, 192.168.100.1 has this MAC address. So let's say it's ABCD. Okay. Now it knows to send data to the default gateway. Okay. So once the data gets sent, because the switch has a MAC address table, it knows what MAC addresses are connected to different ports. It will route the packet to the specific default gateway. Okay. So once the router gets it, the same way it will determine what the next hop is. So that's the reason why I tell you MAC addresses are hop to hop type routing. So the router has what's called a routing table. A routing table is information about what is the best route to get to the destination. Okay, so the destination is in this case on another network over the internet. So it refers to its routing table and it will look at, okay, this does not belong to the network over here. A router will also have other interfaces that connect different parts of an organization. So when it gets a specific packet that's destined for another network, it should be able to route the packet across that interface. So the data gets to the firewall. Now, a firewall typically sits at the edge of an organization to say, if the data comes from this source IP address and this destination IP packet, and it will also check for the port number. I told you, like, there are unique port numbers for web services, for different file transfers, for emails. So your firewall will have rules that say, for this source IP and this destination IP, and for this port number, should I allow or deny this traffic? Okay, so these rules are set up by the company's network administrators. So there will be like a firewall rule table, and it'll have all these rules from top to bottom. So a firewall, as soon as it receives a packet from the router, it'll look at it and say, okay, this is the source IP address, 192.168, and this could be the destination IP address. And it's coming on this port, let's say it's web traffic, and do I have an allow or a deny rule set? Okay, if a packet is allowed, I will send it through to my next hop. Otherwise, I'm going to drop the traffic. Okay. So here, what also takes place is network address translation. So whatever I've shown you here so far is a private IP address. So you might have a firewall doing this, or you might have another edge router also doing the same thing. So it will convert this, private IP address to a public IP. Okay, so let's say it is 152 dot. Okay, let's say this is the public IP address of my organization. So the firewall does that network address translation, and it will send the packet out to the internet. So the internet routers, again, they know what's the best possible way to route this packet to the destination. Okay. So once the packet arrives at this network, it'll also perform the same kind of network address translation. So you might have a destination IP that's routed for the public IP address of this network. So 117 dot. Okay. So an IP packet will typically arrive with the public IP addresses of the source and destination. So the firewall over here will do the NAT, and it will convert this to the private IP address of this destination. Okay, the same thing takes place in reverse. So same request, the same type of translation takes place, and the packet gets eventually routed to your destination. So this is a very high-level view of how a packet gets routed. So I hope you could kind of get a sense of how ports, MAC addresses, and IP addresses work. If you have any questions, let me know. Okay, I think that's all I had for the class today. I wanted to just complete what I had missed yesterday, and thank you for joining. I'll see you in the next class.
Thank you, sir.
Thank you.
Thank you, sir.